Welcome to Your Math Explained, where we make math simple and clear. My name is Angela. Trying to solve a quadratic equation without knowing how to factor is like trying to fix a car without a wrench. You can stare at the engine all day, but you aren't getting anywhere. Factoring is the ultimate power tool of algebra. It breaks down complicated polynomial curves down into simple linear building blocks. Whether you're preparing for a test or getting ready for calculus, consider this your official Factoring Bootcamp. We're breaking down 5 essential techniques, from the basic greatest common factor to advanced variable substitution, so you never get stuck on factoring again. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. The first technique is the greatest common factor, and you always look for this first. The idea is to pull out the largest number and variable that divides evenly into every single term. So here we can see the numbers are 6 and 15. And the greatest common factor of 6 and 15 is going to be 3. Next, we look at our variable. The first term has x cubed, and the second term has x squared. So the greatest common factor between those two is going to be x squared. So therefore, our greatest common factor here is 3x squared, which means you're going to take out 3x squared from both terms, and then whatever is left is going to stay in the brackets. So if you factor 3x squared out from 6x cubed, you're going to get 2x left. And then from the second term, we would have minus 5 left. So therefore, 6x cubed minus 15x squared factors into this expression here. Now the next technique is factoring trinomials of the form ax squared plus bx plus c. When a is equal to 1, we have a simpler case. You play a numbers game. So you find two numbers that multiply together to be your constant c, and add up together to be the middle coefficient b. So for example, the first expression is x squared minus 5x minus 14. So here, the a value is 1, which means we're going to find two numbers that multiply together to be negative 14 and add together to be negative 5. So the two numbers are going to be negative 7 and positive 2. And once you get that, that means we can factor x squared minus 5x minus 14 into x minus 7 and x plus 2. Now, when a is not equal to 1, it's a little bit more complicated. You need to multiply a and c together and then use grouping. So for the second expression, our a value is 2 and our c value is 3. So a times c is going to be equal to 6. And then you do the same thing. You find two numbers that multiply to be 6 and add together to be equal to b, which is 7 here. So the two numbers are going to be 1 and 6. But instead of factoring immediately like in the previous case, we need to first rewrite this expression. So we start with 2x squared plus 7x plus 3. And this is going to be equal to, you break down that middle term. So we write the first term as is, which is 2x squared. Now the middle term, which is 7x, we're going to break it down into x and 6x. So these two numbers being the two numbers that multiplied together to be 6 and added together to be 7. And then we have our plus c. Now this is called grouping because now we're going to look at this two terms at a time. And we're going to take out the greatest common factor from the first two terms. So we have 2x squared plus x. And the greatest common factor between those two terms is just x. And once we factor out x, we would have 2x plus 1. And then we do the same thing for the third and fourth term. The greatest common factor between 6x and 3 is 3. So we factor out a 3, and then we're going to be left with 2x plus 1. So here you can do a quick check. If you did it properly, the two things that are in the brackets should be identical. If they're not, then you've made a mistake somewhere. And now the last step is, of course, you can factor out the 2x plus 1 from both of these terms, and we're left with x plus 3. So this would be the factored form. The next technique we're going to look at is a special case called difference of squares. This pattern is a beautifully quick shortcut. if you have two perfect squares separated by a minus sign. And this is very important. It has to be a minus sign. Then it factors cleanly into the product of their square roots as a sum and difference conjugate pair. So what I mean is if you see something that's in the format of a squared minus b squared, this will always factor into a plus b and a minus b. So here we have 4x squared minus 49. Well, this is a difference of squares because the first term is 2x all squared, and then the second term is 7 squared. So therefore, we can factor this into 2x plus 7 and 2x minus 7. The fourth technique is the perfect square trinomial. Recognizing this pattern is going to save you a lot of time. If the first and last terms are perfect squares, and the middle term is exactly twice the product of their roots, then it compresses into a single squared binomial. In other words, if your first term is a squared, and your last term is b squared, and the middle term is 2 times a times b, then this factors into a plus b all squared. So let's take a look at our two examples here. The first one, we have 4x squared, so this is 2x all squared. And then our c here is 9, which is equal to 3 squared. So now we just need to check whether or not the middle term is exactly twice the product of their roots. So meaning is 12x equal to 2 times 2x times 3. And we can see that 2 times 2x times 3 is exactly 12x. So therefore, this expression, 4x squared plus 12x plus 9, can be factored into 2x plus 3 all squared. Now, same thing for the next one. We have 36 times a squared. So this is 6a all squared. And 100b squared is 10b all squared. So now we check the middle term. Is it equal to 2 times 6a times 10b? And when we multiply that out, it is equal to 120ab. So therefore, our second expression, 36a squared plus 120ab plus 100b squared is going to be equal to 6a plus 10b all squared. Now, a quick note here, since both of these examples had the middle term being positive. If the middle term was negative, then when you factor, this is going to be a minus sign instead of a plus sign. And now finally, the last technique here is factoring with substitution. When an expression looks terrifying because the powers are high, you can change the perspective. You swap out a repeating group of variables for a single letter so that you can make it into a simple quadratic expression. So for this example here, we don't want to factor everything out because if we were to expand things out, we're going to end up with an x to the power of 4. Instead, we can see that we have x squared minus 1 and x squared minus 1. So we're going to let u be equal to x squared minus 1. And then we're going to rewrite the expression in terms of u. So if we do that, we get this is u squared minus 3u minus 4. And this is just your simple trinomial. We find two numbers that multiply together to be -4 and add together to be -3. And the numbers are going to be -4 and +1. So therefore, we can factor this into u minus 4 and u plus 1. But you can't stop here. Because you did the substitution for u is equal to x squared minus 1, you have to make the substitution back. So that means we get x squared minus 1 squared minus 3 times x squared minus 1 minus 4 is going to be equal to u minus 4, so that's going to be x squared minus 1 minus 4 times u plus 1, so that'll be x squared minus 1 plus 1. And then we're just going to simplify the right side a little bit. And we get this is equal to x squared minus 5 times x squared. and this would be our final answer. So now let's do a quick recap of what we covered in this video. We saw that the first step to factoring is always to scan for a greatest common factor before applying any of the other techniques. And in standard trinomials, a positive constant means that once you factor, you're going to have matching signs, and a negative constant indicates that you're going to have opposing signs. And when the expression looks like it's a higher degree polynomial, check to see if you can do a substitution to transform it into an entry-level quadratic expression. And remember, once you factor, you have to always reverse your substitution and get the original variable back. And now it is your turn to give this a try. Can you find the solutions to the problems on the screen here? Make sure to leave your answer in the comments below and let us know what other quadratics topics you'd like to see in the future. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.